Okay, this is chapter 22, once again honors, and this video is going to focus on assigning oxidation numbers. So I kind of summarized how to assign oxidation numbers on the left. You probably want to pause and write it down. Then we're going to practice a couple. So the first thing you want to do is you want to look for a normal boron charge, an alkali metal, an alkali earth metal, ion that's part of something larger that's definitely like a +2. So some very clear ionic charge. The next one is you want to try to work with hydrogen. Hydrogen's usually +1, except for these hydrides. In lithium hydride, hydrogen's -1 because the lithium must be +1. And in sodium hydride, hydrogen's -1 because the sodium must be +1. So those are two exceptions. I don't think you'll see many other exceptions. Those are probably the ones you'll see. The oxidation number, or the charge, I should say oxidation number is fancy for charge, of oxygen's -2, except for a couple. So in sodium peroxide, sodium has to be +1. And in order to balance out that charge, the oxygen would have to be -1. So that's one exception. Same thing happens with lithium. Lithium must be +1, which forces oxygen to be -1. And lastly, hydrogen must be +1, which forces oxygen to be -1. So just a couple exceptions. The oxidation number for a neutral element is 0, so if that's how you find it in nature, then it's just 0. If that's how you find it in nature, it's just 0. Remember, most of your elements are like this. There's 7 diatomics, and then every once in a while you run into something weird like a P4. You'll go, just must be 0. The sum of the charges must equal the charge on the compound. So the charge of sulfur plus the 4 oxygens must equal -2. The charge on potassium, 2 potassiums, 2 chromiums, and 7 oxygens must come out to equal 0. So those are the rules, basically, and then we're just going to practice them. So S2O3, I go through my rules. I have no clear-cut ion. I have no H. I do have an O that's -2. So I'm going to allow the O to be -2. And then I'm going to think, this is how I think, this is my brain. If I have 3 -2s, that's -6. I know they have to equal 0 because there's no charge there. So -6 plus some mystery number has to equal 0. Well, that number is going to be +6. So that +6 charge will be spread over 2 sulfurs. So each sulfur is +3. So I would say sulfur is +3 and oxygen is -2. Let's try another one. Fluorine. That's just how it's found in nature. So that one's super easy, 0. F is 0. H2O2. I go through my rules. H has to be +1. I'm going to think it through. Even though I know it's there, I'm just going to pretend I forgot. If I have 2 +1s, that's +2, plus a mystery has to equal 0 because there's no charge. Well, this mystery has to be -2. The -2 must be distributed over 2 oxygens. Therefore, each oxygen is -1. So H has a oxidation state or charge of +1, and oxygen would have a oxidation state of -1. P2O5, no clear-cut ion, no hydrogens, oxygen. I literally am going down my list. Oxygen. Oh, oxygen's -2. because it's not one of those three weird ones. I'm going to think. Here's my brain. I know it has to equal 0 because there's no floating charge like over here. Negative 2 times 5 is negative 10. Negative 10 plus a mystery has to equal 0. So that must be a positive 10. The positive 10 distributed over 2 phosphoruses will be positive 5. So phosphorus has positive 5 and oxygen has a negative 2. Let's try 4 more like that. So the oxidation number is equal to the same rules over here. I don't know why I started to read them to you again. NH4, there's no clear-cut ion or charge. I do have hydrogen. It's +1. So hydrogen's +1, and I have 4 of them. So 4 times +1 is +4. I know it has to equal a charge of +1. So what number +4 equals +1? Has to be -3. -3 distributed over 1 nitrogen is just -3. So nitrogen would end up being an oxidation state of -3, and hydrogen would be an oxidation state of +1. Okay, let's go through and do this one. Sodium dichromate. There is a very clear charge. Sodium is in the +1 column, and it just is +1. So +1 is my brain, times 2 is +2. And I know it has to equal 0 because there's no charge. Going down, there's no hydrogen. Going down, there is an oxygen. Oxygen is -2 times 7 is -14. So I know some mystery number. 2 minus 14 has to equal 0, so my mystery number is 12. 12 must be distributed over 2 chromiums, so each chromium would be +6. You should realize as you're watching these, hopefully, that as you feel confident, you're pausing, trying them on your own, and just checking your answers. There's no need to watch me work each one out. The next one, aluminum sulfate. Well, I feel like aluminum definitely is a +3, so I'm going to give it a +3. I know it's 0 overall. So 3 times 2 is +6. All right, next guy. Got oxygens. No hydrogens, but I've got oxygens. Oxygens -2. Be careful, I have 12 oxygens. So that's -24. So we need to figure out my mystery number. 6 plus a mystery -24 has to equal 0. I believe it's going to be 18. Let me just think it through. Yep. 18 distributed over 3 sulfurs is going to be +6. Okay. One more. Calcium hydroxide. Calcium's a clear-cut charge. Oxygens -2. Hydrogens +1. Everything worked out. I'm going to take a minute just to double check it. Let's see. 1 calcium, 2 oxygens, 2 hydrogens, and that works. So sometimes there is no fill in the blank one, and that's okay. Okay, on this one, I'm going to assign oxidation numbers kind of quickly. So I would pause, assign, and check. So I have a 0, +1, and then a -2. Hydrogen is losing 1 electron. So hydrogen is oxidized. And since hydrogen is oxidized, then the H2 is the reducing agent. If you look, oxygen goes from 0 to -2, so he gained electrons. So oxygen is reduced, but O2 is the oxidizing agent. Feel free to pause and try the next one, and then join me when you feel pretty confident. +1, -2, +5, +1, -2, +3, and 0. You can see the order I did them. +1, -2, +5. So you could do the brain thing. You should be able to do this. In this one, nitrogen's going from 5 to 3. So I'm just looking for who changed charges. 5 to 3, he gained 2 electrons. So nitrogen is reduced, which means the compound containing nitrogen is the oxidizing agent. I see that oxygen, not all of it, but some of it went to 0. And that's okay. So oxygen, some of it changed and lost 2 electrons, which means it was oxidized, which means the compound containing oxygen is the reducing agent. So that's kind of weird that he's the reducing and the oxidizing agent, but actually it makes it very easy for the electrons to hop around. They're right next to each other. Okay, assign the next charges. It's going to take me a minute. This one takes a little savvy. Look what I'm going to do. I'm going to split them up. It's ammonium nitrate. In the ammonium, the hydrogen is +1, which will make the nitrogen -3. However, over here, the oxygen's -2, which will make the nitrogen +5. So that is really weird. It has 2 different charges in one compound. So it looks like the nitrogen is losing electrons in this case and gaining electrons in this case. So nitrogen is oxidized and reduced. And the compound containing nitrogen is both the oxidizing and reducing. Oxidizing and reducing agent. So that's kind of weird. Let's try again. This one, I'm going to assign my charges. Look at the order I do them. That'll help you. Lead's a definite +2. Iodine's left over. +1, -2. I'm looking for changes here. Woo, I'm throwing pins rather. Lead changed charges. Oh, and some of the iodine changed charges. So it looks like the lead went from +4 to +2, so he gained electrons, so is reduced, which means the compound with the lead is the oxidizing agent. I went from -1 to 0, so I is oxidized. And the compound containing I in the reactant side is the reducing agent. Okay. I'm going to do one more with you. Sometimes you're asked to determine if it's a redox reaction. You must have a change of charges. So I'm going to go through and assign charges, showing you the order, but go ahead and pause, give it a good try, and then check your answers. So barium is a clear ionic compound, forcing chloride to be -1. Potassium has to be +1. Oxygen has to be -2, forcing the I to be +5. Notice I don't really care about coefficients, by the way. Barium is a +2. Oxygen has to be a -2. I might think here, this one's got some thinking, so here we go. +2 has to equal 0. I have -2 times 6 is -12. This is going to be a +10, split over 2I, so it's back to +5. So sometimes I have to do my brain. Potassium is in the +1 column, forcing Cl to be -1. I'm looking, did anyone change charges? Nope. Cl? Nope. Potassium? Nope. I? Nope. Not a redox. Okay. So I'm gonna keep doing that. Hydrogen and oxygen are assigned. Carbon will fill in the blank. Hydrogen and oxygen are assigned. Oxygen's assigned. Carbon will fill in the blank. Hydrogen, carbon, oxygen, not a redox. Magnesium and bromine are found that way in nature. Magnesium in an ionic compound has a clear charge. Bromine takes up the slack. Yes, redox. Because I can see clearly that magnesium changed charges and bromine changed charges. This guy, I feel like I failed to put an arrow. Hold on. I believe the arrow goes here. That wasn't much of a reaction, was it? Let me double check. Into water. Yep, that works. So let's turn that into a 0. Nothing like making a mistake on a video. So we already did this one tricky before. So let's look at NH4 and NO2 separately. The NO2, the O is a -2, forces the nitrogen to be a +3. So +3 minus 2. The H must be a +1, forcing the nitrogen to be a -3. -3, +1. This nitrogen's neutral. Hydrogens are +1, oxygens are -2. Let's see if anyone changed. Nitrogen definitely changed. In fact, nitrogen did all the changing. So I would say yes, a redox. Let's try another one. I'm going to do the obvious positive. Oxygen has to be -2. I'm going to let chlorine fill in the gap. Potassium has to be +1. Chlorine fills in the gap. Oxygen by itself is neutral. And I look for charge changes. Chlorine changed. and oxygen changed. So yes, a redox. This is good practice just to assign redox numbers. Let's try another set. Calcium's a clear ion. Oxygen must be -2. Carbon's going to fill the gap. H has to be +1. Chlorine fills the gap. Calcium's an obvious ionic charge. Chlorine fills the gap. Hydrogen's a +1. Oxygen's a -2. Oxygen's a -2. Carbon fills the gap. And I look for change of charge. Calcium to calcium, nope. Carbon to carbon, nope. Oxygen to oxygen, nope. H to H, Cl to, no, not a redox. So I'm looking for the change of charge.